original, I would say, contribution to this field is that that kind of interaction results in a synergistic enhancement of surfactancy. So traditional approach, you can find probably thousands of papers, how surfactant affect different proteins, enzymes, and so on. Usually they inhibit them, and they unfold them, and so on. But what we found is just the other way around, how proteins empower surfactants, and that's our contribution to that field. So we found that actually proteins form pretty strong, tightly bounded complexes of surfactants. Our proteins actually, they come from baker's yeast. We do not do any isolation of purification, otherwise it would be economically unviable. So we actually use them as the eye in the fermentation broth, which makes it kind of doable in terms of industrial applications. The surfactants may be synthetic, bio-derived. They can be anionic, cationic, non-ionic, amphoteric. So it's a broad spectrum of surfactants, and with all of them we actually found that effect of enhancement of surfactants. So these complexes, they're stable and functional in a very broad range of pH, which is important because sometimes you need highly alkaline solution, sometimes acidic, but in most applications that we apply, that we use, it's pretty much close to the neutral. That's why the product itself is non-toxic, safe for the crew, and so on. It's important also that it's stable at high temperatures. So, for instance, we can heat it over 90 centigrades for quite a few hours, and surface activity is still there. And they are compatible with strong oxidants, which makes them quite appropriate for instance, for creating new disinfection, sanitizing tools, and so on. So basically, these complexes, they display two features that Robert already mentioned. So the short-term effect is just increase in the efficiency of surfactant, which is kind of measurable quantitatively in terms of surface tension, interfacial tension in oil-water system, critical micelle concentration. We can see the effect of facilitating wetting, spreading, penetration, uptake, solubilization, and so on. So this is immediate short-term effect. Whereas a longer-term effect, which is related to the interaction of the product with the existing nature of the present microflora, bacteria. So that is important when we apply our product in wastewater treatment, or for instance in bioremediation of the ocean water contaminated with petroleum oil. So that's of course a longer term effect because it's associated with microbial cycle which takes time. We use entire arsenal of the surface science methods, which I will not stop, but typical examples are for instance, that's bend and drop method, and you will see some results, or contact angle method, and that is typically what people use in that kind of area. So for instance, we can see how the critical micelle concentration of synthetic surfactant shifts downward when we combine the surfactant with our protein. In certain cases, we can dramatically decrease the CMC, and it's important to understand that CMC actually that's the concentration where surfactant works as surfactant, because lower than CMC, it doesn't really, clean anything. So here, for instance, for a mixture, a very efficient mixture of two surfactants, we have a downward shift from 150 to about 8, which is a considerable effect. And we found that, rule, I would say, with all kinds of surfactants. So you see that first line is surfactant itself, second line with protein. everything is going down in each pair of surfactant that we try. In certain cases, it's very important to get extremely low interfacial tension with petroleum, oil, for instance, water interface. In this case, with some proprietary surfactants and our proteins, we achieved a record low interfacial tension, which is important, for instance, in oil industry and oil production, enhanced oil recovery. Here it is the bilge removal, removal of diesel actually in that case from bilge water. So we compared an industrial surfactant, that's the blue line, so you can see that you could only remove about 2/3 of the contaminant in relatively long time period, and the cleaner, by the way, is highly caustic. It's actually 50% sodium hydroxide. With our product, we achieved that level in about 20 minutes, and by a couple hours, it was gone completely. So now I will show you the effect, how we, the oil herding effect. We have a patent application on this method. Sure. Let's see if it works.
May not work on that system.
The movie?
No, yeah, it must work somehow.
I'll show them that. I'll put that on.
Separate movie.
Later, so you can see that.
Okay, prepare yours. I don't know. Okay, let's see. Next one. Maybe this one will be better.
Mine's an apple, you know, it works. Go ahead, you keep going.
Okay. So that's Robert will show us this movie, but which is impressive in my view. So now the other side of the effect of the the synergistic enhancement of surfactants with our proteins is that the product actually interact in a positive way that with naturally present microflora, and that can be seen out of the effect of the activated sludge, which is taken from wastewater treatment. In that situation, you can see that part of the grease which is accumulated in the wastewater, it's actually converted through the participation of the microflora into soap-like compounds. So it's a kind of self-enhancement. We put certain surfactants which are in contact with protein, and then they actually force the bacteria which are present there to convert part of the grease into surfactant and soap-like materials, which again enhance the cleaning power. And that's how it actually works in sewer lines, in wastewater treatment plant, and greatly enhance the efficiency of the cleaning. So we can say that enhancing bacterial processing of grease into surfactant, we convert the sewer line into wastewater pre-processing reactor. So this way we can improve the quality of the effluent of the municipal, for instance, municipal wastewater treatment plant. Well, are you ready?
Yeah. Everybody see this?
Mm-hmm.
Okay, so this is the herding effect. This happens to be Texas light crude. And then I'm going to show you, so this is about 800 parts of oil to 1 drop of our product, part of our product. So that.
police here.
Okay, so what it's doing is it is driving the oil into an absorbent boom, and we just got back from Calgary, and they're talking about doing it into peatmoss, actually, which is a good idea. And in the ponds, so here's another one. This is heavy crude, so that was light, so it kind of flowed over the top. This is a heavy crude. It was the same amount of oil, by the way, it just coagulates differently. Again, same immediate effect. So we also have a video of that in the Gulf of Mexico where the BP took us out. I was there, by the way, for 31 straight weeks, so I did everything. But it was, they actually took us out in the water and demonstrated this on weathered crude out in the water. So it's absolutely scalable. It works at any size, just a bit. It takes very little product to do it. So the best idea is to collect the oil rather than disperse it. Even though we can disperse it, best idea is to collect it if we can. So we could drive it to a boom a quarter of a mile apart or half a mile apart and send it in the direction.